All right, so we are back out at the drone park today. We have some people that are interested in learning. So we have what looks to be the same developer that we've been using. It's actually not. And just to give a little bit of context, we took this developer and just grabbed the top cover from it. And that includes both the GPS and the telemetry radio, so we're going to keep those the same. Obviously a different flight controller and different ESC. While I think this developer could be all right, just disabling the compass on this flight controller, we had a commenter and viewer of our last video suggest that he's had a similar problem that was caused by the ESC having failed on him or potentially being delivered in a failed state. But this was previously working with the ESC that has been installed. So unless that ESC gave out after a crash or some other problem arose with it after its first few successful flights, I don't think that's the case, but we should be able to determine what is the cause of this developer not flying correctly if this one is flying correctly. But in any case, let's go ahead and set this developer up with the right parameters. Going to start just by plugging in our USB-C to USB dongle, and then coming over to the USB-C port on the developer, plugging our computer into it. And just what we want to do, use open source software made by developers for developers. Not really, because ain't nobody got time for that except me and these people. This developer has already been previously set up, but I don't think correctly. Pointing the finger at one of our interns that was getting some practice on the developer building front. But we are going to reset this back to the firmware defaults and reset it up as if it were a brand new developer built, which kind of sort of is. So I just hit reset to all firmware defaults. I'm going to reset again, and then we're going to reboot, and everything should actually be reset back to the firmware defaults. As you saw, Q ground control just crashed, as it has a bad habit of doing. It crashed out, as the Zoomers would say, right? That's the term. It cooked out, as I would like to say. Had a nice barbecue. All right, and so we have Q ground control back opened. All the parameters were indeed reset. You guys should already know this by now, nodding like of course you do. We have all of our documentation to set up developer as it should be on the iVue Robotics website. Again, just going to the download section and clicking any of these download icons, that'll bring you here to this folder. If you go into the base XE-HP subfolder, you'll see all the parameters in the document. So just getting Q ground control pulled back up, going to the parameters tab in Q ground control. First things first, we're going to set the frame class. If you watched the last video, maybe 2 videos ago, you could see there's another way to set this, but we're going to select frame class and hit quad, hit save. And then frame type is X. That's already set to X by default. If you saw the last parameter we just set for the frame class requested that we reboot the vehicle. That's not strictly necessary, but we're doing so anyway. All right, and we have rebooted. We're running a slightly different or slightly older version of the RG-Copter firmware, 4.6.0 versus 4.6.2, which is running on that other developer, but still a new enough version that maybe is a cause of the problems that we're seeing, but I highly doubt it. All right, and then the next parameter is disabling the safety switch. Board safety default, we need to set to 0 or disable it. And I clicked the wrong one. And just selecting disable from the drop down. Again, it's going to ask that you reboot. I'm going to disregard that request right now and move on to setting up the ESC. We just lost our internet connection, it seems like. I don't know why, because we have a hotspot going, but we should reconnect here. Serial 5 protocol, we're setting to 38, or the FETTech one-wire protocol. And then we're making sure serial 5 options is already set to 0 as it is. The PWM values for the motors are set to 1000, 2000. Those should also be that way by default. We're going to go ahead and reboot. Let Q ground control crash. We'll reopen it. At least Developer doesn't crash as much as Q ground control. Looking at the silver lining. Call me Mr. Brightside. I've been coming out of my cage. I've been doing just fine. Any of you know that song? All right, look at that. Cultured people. Servo 2, we are switching to motor 3. Again, we've covered that in a recent video, but basically the orientation of the FETTech 4-in-1 ESCs have the motor 2 and 3 positions swapped. So we're just switching that via software as well. So Servo 3 is actually motor 2, and Servo 2 is actually motor 3. Motors 1 and 4 stay the same, so we don't have to adjust those. We need to enter in how many motors we're looking for that FETTech one-wire protocol to control. That's 4 motors being a quadcopter. So, this totally makes sense for non-developers. We need to set this value to 15, or if you just select the first 4 servo options, it sets it to 15. Now we need to tell motors 3 and 4 they need to reverse direction. So servo FTW RV mask, we're setting to 12. Or if you were to see here, selecting servo 3 and 4 checkboxes, we can just hit save. All right, now we need to set the battery, RC, and ground control fail safes. BAT FS CRT action. So when the battery gets to a critical level, the action is going to be land. When the battery failsafe just gets low but not critically low, the action is going to be Smart RTL or Return to Launch, whichever is available. FS low action. All right, the throttle failsafe is going to be disabled. So basically, if developer is not receiving any controller throttle input, it can still continue on its mission. Similarly, if the GCS, the ground control software, cuts out, it will automatically return to the launch location. Enable with this parameter being set to Smart RTL or land. The next parameter, again, we've covered all of these, but if you haven't caught that video, we're just adjusting the timeout duration. So if you lose access or connection to your ground control software, after 3 seconds, that failsafe will be triggered. Now we're setting the arming checks. Again, just disabling the RC and parameter checks. This you really want to go ahead and enter in manually. So scroll down, select advanced settings, select manual entry, and then we need to enter in the number 65,470. 65470. All right. And then RC options, we need to set to 0. And that allows us to use developer without any sort of controller, without running into any like fail-safe issues, any unnecessary fail-safe issues. All right. And then this is more of a safety parameter that we set. So if we were on the other side of trees when developer loses connection, setting our return to launch altitude of 150 feet. in centimeters, 4,572 centimeters. Should get above any trees or other obstacles in the way. Adjust the landing speed. Again, not strictly necessary, but we're going to lower that to the lowest default option is 30 centimeters per second. And then we need to enable what's called sag compensated voltage. So as develop air is actually flying, it will use more voltage from the battery than if it were just plugged in on the ground. And so to compensate for that extra voltage, instead of just reporting the raw voltage output, we're compensating for that battery being used in flight. The power monitor board, that's pretty critical. Given the battery status lights aren't actually going to be operational for this flight test, one of the 4 lights is actually not installed on this model here. So basically the lighting system on develop air is wired up in series. So with that 4th connection not being there, the connections 5 and 6 for the battery status lights won't come on, even though those are plugged in. All right, battery monitor. We're setting the battery monitor type to its INA2XX. Not exactly sure what that actually means. I think it's just like the processor that the power monitor board uses. Battery I2C. Bus, that parameter is not available until we reboot. So let's go ahead and reboot. Let Q ground control crash, and then wait for it to reestablish a connection. Parameters, and now we could search bat I2C bus. It now appears, and we set that to 2. It's going to ask us to reboot again. We're not going to do it just yet. Now we're setting up the Lua script for the power or battery status and position lights. Again, we're not actually going to see those function. We should actually see like 3 of the lights function, but not really necessary for this flight. Servo 9, we're changing to script 1. Again, you could select that from the drop down or manually enter in 94. All right, and then battery settings. We use a standard 4S 8,000 milliamp hour Li-ion battery, lithium ion, not LiPo. Same chemistry, just different form factor, at least in most cases. The low value is, I forget what is 2,444 out of 8,000 in a simplified fraction, roughly, or even a percentage, I guess. Come on, smart math people. 8,000 is a fully charged battery, and then 2,444 is our low state. And then the critical value is 1,222. So that's like 15%-ish, something like that. Incalculable. 1,222. Battery low voltage, that's set to 14 volts. Battery critical voltage set to 13.33 volts. Battery low timer, again, this is how long it will take for the battery to be at that low state before actually triggering the fail-safe action. And then the arming voltage means we can't arm with a battery that's not at least, I think it's like 60%-ish charged, is what 14 volts equates to. 14 volts. All right, and then yaw rotation speed, pilot Y rate is to 60. So we're basically, if you had a controller, which we don't for these test flights, just adjusting how fast it's going to spin around when you use controller input to spin it around. All right, those are all like the really essential parameters for Develop Air itself. Now to set up the telemetry radio, we need to set these serial 1 parameters. SR1 extra stat is 2 hertz. SR1 extra 1 is 4 hertz. You can see in the document what each of these do. But let's see, SR1 extra 1 is 4 hertz. SR1 extra 2 is also 4 hertz. SR1 extra 3 is 2 hertz. SR1 parameters is 50 hertz. SR1 position is 2 hertz. SR1 RC channel 1 hertz. All right, and then lastly, the serial 1 options. Serial 1 options needs to be set to 4096, which again needs to be set through the advanced options, or just select ignore stream rate, and now we can reboot. So before we actually go set Develop Air out in the field, we're going to at least make sure the motor directions are set correctly. That's pretty crucial to achieve flight. Everything else we'll actually see if it was set up properly in an attempted flight. So let's go ahead, let Develop Air catch on. It already has a satellite connection connected to 17, now 18 satellites. All right, all right, all right. I'm going to disconnect from USB, and actually I lied. I'm going to keep it connected via USB. I was going to do the motor testing via the radio, but while we had the USB plugged in, all we need to do is plug in the battery. Now we should see the ESCs run properly. We should see this warning go away here momentarily. It would go away if I just go to the vehicle configuration screen, but just to verify that it should go away on its own. Nope, not yet. Let's go ahead and do a motor test and see if that message just hasn't gone away as it's supposed to. Not spinning. Okay, so yeah, I did not parameters. Now I'm thinking about it, I do not recall setting the min arm speeds. Okay, I did not. So don't pull a me and try to rush through the document. Let's see if that's all that's remaining to be set up. Vehicle configuration, parameters, mote, spin, arm, manual entry is 0.04. So basically Develop Air needs to receive a signal of 4% or more to the motor to be able to spin it, out of 100 of course. Mote spin min, we're going to choose 0.07, again entering that in manually. All right, tools, reboot, okay, reopen. That doesn't sound right. We should have received more beeps. We got the beeps, we got the beeps. Yeah, we got the beeps. That's not great. No motors are spinning. That is fake and gay. All right. This Develop Air might not get flight tested today, so let's go ahead. We'll swap out the top cover for the other Develop Air that we've been flight testing, We'll need to do more troubleshooting with this ESC, it looks like, at the office, not properly set up and configured. But what we'll do to just try out testing that's different than what we've done previously is disable the compass built into the flight controller on this developer. So that will absolutely 100% positively speaking narrow down the issue to the ESC, because if it's not the compass built into the flight controller, it's got to be the ESC, and that looks to be somewhat likely to be the case, seeing as this ESC is giving us issues as well. So just going to unplug the battery, disconnect USB, take off the top cover. Taking the top off, all right, getting some action. Just plugging in the GPS, plugging in the telemetry radio. Gonna take the battery from this one. If this developer flies at least somewhat properly, even rotating, we can call this video 2 drones, 1 flight. What's so funny? You guys like, there's like another video maybe that's kind of names. Wow, Jacob, you want to try telling some funny jokes? I got these nice wobbly boom arms as well, totally what you want, but thankfully Akilish is helping us solve that problem with more nuts in Develop Air. Just what you need, more nuts. Yep. And specifically back over yonder. So with this newly built Develop Air that hasn't seen a lot of crashes and a lot of flights, the boom arms are very stable, as again you would have seen in one of our older videos. These boom arms are very wiggly, and so that will just happen over time with vibrations of flight, but then of course also coming into the ground, hitting the boom arms up against the ground will also eat away at some of that plastic material around the screws. And again, these screws just dig directly into the plastic, but now there will actually be hex nuts until we have Develop Air with a folding boom arm design, which is coming. All right, let's go ahead, plug this Develop Air in, or the radio in, to connect to that Develop Air. Not getting any warnings in Q ground control, so I think we should be good in the iVue RC app as well. But before we switch over to the iVue RC app, we're going to disable the internal compass, the one built into the flight controller. So going down to sensors, sensor settings, the internal compass, just deselected it. I'm going to reboot while we're in here in Q ground control. Make sure that we're not getting any like compass error issues, at least that are being reported. And if we see continuous rotation, then we know it was an ESC problem, or is an ESC problem, or at least much more likely to be an ESC problem. And if we achieve straight and level flight, actually bring this Develop Air out was not necessarily for nothing, but kind of sort of for nothing. All right, let me put into loiter flight mode just to make sure that need position estimate. Okay, we got the position estimate. So now we can open up the iVue RC app. It's already opened here on my end. Going to need to reconnect. All right. So seamlessly connect your computer to the hotspot just as we did. Open up the iVue RC app, hit connect to drone, select the STM32 radio from the drop down, and look at that, we are connected, ladies and gentlemen. The connection I've always been waiting for. All right, now it's prop time. We have any betters of whether or not we're going to achieve takeoff, if we're going to achieve takeoff with no rotation, or if we're going to achieve takeoff with rotation? Yeah, like it's spinning around, like a record baby, right round, right round. Every now and again, this prop adapter and prop likes to give us some struggles. Give me some struggles. I am the struggle. There we go. Sometimes the threading on these props don't align with the prop adapters as much as they really should. All right. Leroy Jenkins, let's do this. Cass, I'm gonna need a number crunch. What's our probability of success?
About 32.33.
Of course. All right. Fly drone. Arm and fly. Dun da da dun da da dun da da da. Mother lover. Like you just don't care. Say hey. Say the best landing you'll ever see. The greatest landing. Hey, at least it disarmed by itself. All right. So yeah, it looks like it's probably an ESC problem. So one step closer to identifying and fixing the problem, but it looks like the rest of that identifying and fixing is going to at least happen at the office, and then we'll see the results of that fix in our next video here in the next couple of days. So thanks for watching, but you'll see us in the next one, and I guess sorry that let you guys down with such a disappointing show.